And I can. It's started slowly.
Okay. Is anything working here? Firefox is asking me to. Okay.
I can't see your screen yet, but.
Okay, give me 1 second here. This is the
Stefan,
Firefox setting.
we got you here as well.
Yes, can you hear me?
Yes, we can hear you.
Should I be prepared to share my screen?
If it works for you, otherwise I can drive the slides. It's fine.
I can just check. Should I check it right now?
Maybe it's simplify.
Let's see which one. Yeah, but can I choose? Yes, I can choose. I can choose share screen 2. Okay.
Yes. Yeah.
That's great. Good. And I can stop sharing there. Great.
That works.
Then I'm prepared.
Perfect.
Francesca, I think you might have to drive my slides. I don't want to restart Firefox right now.
Sure. I'll prepare them.
Thank you.
No worries. But I'm sure that's okay.
Yeah, I agree with your assessment of the time. I think we can probably go ahead and get started.
Patch working group. Thomas, feel free to mute yourself and stop the video as well if you want. This is an IETF meeting, so the note well applies. Please take some time to read and understand what is written here if it's your first session, and reach out to us if you have any question. This is a slide about this IETF109 online meeting tips. Just as a warning, this session is being recorded. Make sure your video is off unless you are but if not, it doesn't matter by now. The blue sheet are automatically generated, so no need to worry about that. Yes, we have a chat that is synced with Jabber, so you should be able to use either one of those, and we will be monitoring the chat. And for more information and assistance, there are 2 links that are useful. And yes, let's move on. Some more links which are specific to this session. We have our Mythico, Jabber, the minutes. Thank you to our minute taker, but anybody, please help out, especially if you have a comment to the microphone, just go to the minutes and check that it was correctly captured. We have the link to the slides. There is our emails. I am Francesca Bini, co-chairing with Kathleen and Richard here. Our mail list, our charter, and a link to our wiki. We have quite some time today. We have this. We are now in the intro part of this presentation, and after that, Thomas will present interoperability architecture for blockchain gateways. He has 30 minutes. And then Dane from IoT Security, Shomon, I hope I'm saying your name correctly, for 30 minutes. And these are the 2 items that we need to dispatch today. Then we have the signature validation token SVT update, Stefan. And I just want to remind that this is not a topic to actually dispatch. This was dispatched at IETF107. But since this was, since we had time today, and this we requested some time, this was requesting some time, we added it to the agenda. Yeah, I see that Stefan is in the queue, so go ahead, Stefan.
Sorry, I completely misunderstood them. Intention for participating with this presentation today was that it should be dispatched today, because what we did last time was make a presentation, but we never dispatched it. We decided to create a email list that we never created. So this is the time where I would expect this item to be dispatched.
We did discuss it and dispatched it in an appropriate way, which was create a mailing list to get to see if there was interest to move it in forward. And according to the charter, once items are dispatched, they should not be brought back, obviously, unless there is some substantial changes.
Which I think there is. So could we at least have the discussion and then decide whether we want to dispatch it?
So this is Kathleen. The list not being created was probably a backlog item. So I'm assuming perhaps it just didn't get done for administrative reasons, not for any purpose. So we do plan to have the discussion, but as Francesca said, it was dispatched. So let's make sure a list does get created this time. So Stefan, we'll need your help on that, and then the ADs as well.
But our proposal might be to put this actually in a working group because we think it fits there, and then it would be unnecessary to create a list, because it would be better to discuss it in the working group where it could be dispatched. Or is it completely impossible to add a working item to a working group if it has ever been discussed in the second dispatch?
No, that's not,
like Ben wants
that's
to
not impossible. But let's hear from our AD. Ben, go ahead.
Yeah, I mean, the short summary here is that, yes, we did attempt to dispatch it to a new mailing list, and the list didn't get created, and that's just because the ADs didn't follow up and we didn't get a reminder about it. So in order to create a list, we need a few pieces of information. Some of those we can't actually guess ourselves. So Stefan, if you could please follow up with us after the session, we can get you the list of pieces of information that we need to create the list. There's no problem creating a list and then later wanting to create a working group. We can reuse the same list if that is appropriate. So I think the best path is to get the list, and then if we have interest and we want to turn it into a working group, we can proceed using that list as well.
We can take it later, but the idea was not to create a new working group, but to fit it into one of the existing working groups.
Oh, sorry, I misheard your
in that
earlier.
case, it would be unnecessary to create a mailing list. That was my only point.
I see.
We can talk it later. Take it later.
Okay, but yeah, let's take it later and continue this discussion during the time slot. We'll have time anyway. Yeah, 25 minutes open mic, and then conclusion by the chairs. So the dispatch process, this is just a reminder for everybody that the SECDISPATCH recommends the next steps for new work. It does not adopt drafts or does the technical work in the working group. So possible outcomes of dispatch of this session today will be to direct the document to an existing working group, propose a new focused working group, AD sponsorship, assuming AD is willing, additional discussion on or community development is required, and IETF should not work on this topic. Those are all valid dispatching outcomes. And just to underline, or to go back 1 second to the previous document, I think that the dispatching outcome last time this document was discussed was additional discussion or community development was required. But let's take it later so we can move on. So just a quick run through the participation guidelines. When you're at the microphone, please state your name before speaking if you can remember. It helps with the minutes taking and also for the recording. And keep the dispatch question in mind. So it's great to have comments and feedback about content, but please try to keep it constructive and also give advice on where you think this work should go, if it should go anywhere. And keep your comments quick if you can, 2-3 minutes. We have more times today, so we're less strict about that. To speak, you'll have to join the queue, which is the hand icon. And then once you're given the floor, you can send audio and video if you want. And then there is other controls, such as show of hand, which I'm not sure we will use today, and the chat, which is synced with Jabber, as I said. And yes, one slide for show of hand. But we can move on to the first topic to dispatch, which is Thomas. So please.
You guys hear me?
Yes. So let me just check.
Okay. Thank you, Francesca. Okay, so I just get started?
Yes, go ahead.
Okay, sure. So I just want to say thank you to the SecDispatch chairs and also to the ADs for the opportunity. I think the goal of this presentation is just to make folks aware of this ongoing effort and to invite people to participate. So this is just the outline of the presentation. I'd prefer to finish the whole thing so that everybody knows what's in scope and what is out of scope. And then if anyone has any specific question about any specific slide, you can always go back and the slides are posted, so you guys can actually read ahead of me if you have questions. Next slide, please, Francesca. So what's the problem statement for folks who are following the whole blockchain DLT discussion narrative, and for folks who are following the discussion about decentralized finance and DeFi, it's very clear that the industry is still in a nascent state. We have very poor interoperability between systems, and right now, if you want to do asset transfers, virtual asset, and I'm using the word sort of generically, you typically have to ask help from a third-party entity, which is in the industry typically called crypto exchanges. And in the United States, there's about, I don't know, between 25 to 30 crypto exchanges. Some of them are well-known, Kraken, Coinbase, and so on. And so the problem there is, in fact, the crypto exchanges themselves become a centralization point, becomes a choke point. And it in fact goes against the whole sort of ethos of decentralization and autonomy, right? If you're dependent on a third party to do anything outside your system, well, you're kind of constrained. You're not really autonomous. And in some cases, it could lead to asset lock-in. So for those who paid attention to the CryptoKitties incident, it pretty much put Ethereum at a halt, which means if you had assets there that had nothing to do with CryptoKitty and you're trying to exchange it, you're impacted by that. Next slide, please, Francesca. So this is a quick diagram for those who don't know, I like to use visuals, being an engineer. So this is kind of what it looks like. There's an exchange entity in the middle. Next slide, please, Francesca. And so what we think we need is a specific model between two DLT systems based on gateways. So we need standardized protocol. The protocol needs to be agnostic to the economic value. And right now, if you read a lot of the literature, there is a lot of confusion between the notion of economic value. And in fact, some people are now even questioning, what is economic value? Like, and so these gateways stand in front of their DLT system. Each DLT may have multiple gateways. So there's these questions that we need to answer, such as, how do you pair up a gateway? How does a DLT system elect or select a given gateway, to talk to another gateway? And I just noticed there's a typo there. The second gateway should read G2, not both G1. So it's G1 and G2. My apologies. Next slide, please, Francesca. So this is kind of what we are looking at. The model here is that you have gateway G1 and G2. There is the protocol in the middle. We've been calling it generically the gateway protocol, but we actually have a draft there, the Open Digital Asset Protocol, or ODAP. And this is draft Hargraves, dash ODAP. If you just Google that. And the model assumes that on both sides there are resources. So instead of talking about blockchains or DLTs, we just talk about resources. There are interior resources to a DLT system, and there are exterior resources. The interior resources, whatever the DLT is using, it could be its own ledger, it could be the public keys, it could be consensus protocol, if you want to call that a resource. And there are things outside any DLT which are off-chain resources, what we've been calling exterior resources. And those are things like asset depositories that can actually perform validation of the true nature of an asset. So one of the problems today is that there's no definitive entity authority that says, well, okay, this is a stable coin that's coming out of this group. So even if you guys are following the whole Libra thing, Libra version 2, which is actually a stable coin, question becomes, what is the legal status of that organization when they proclaim that this is a stable coin coming out of Libra, right? So that's kind of out of scope. But let's say, for example, in this discussion, the client wants to affect the transfer across G1, G2. Well, G2 and G1 need to understand that they're talking about that very specific asset, and there's no discrepancy, right? So we'll talk about that later on. But this is the model, and the scope of work for the IETF is that in the middle there. Just get G1 and G2. What happens in between? What does G1 and G2 need to have in terms of capabilities in order to perform a unidirectional transfer? Next slide, please, Francesca. So this is in a single long sentence. What is it that we want to develop? So it's a gateway to gateway protocol that allows the secure transfer of a digital asset representation. So I'll just put it that way. We can talk about what's the definition of a virtual asset. It's unidirectional. So we want to focus just on a one-way unidirectional transfer and get that working, because I know there's a lot of interest in industry with a thing called atomic swaps, if you guys know what that is, which is a dependent, two-directional transfer. And there's some issues there. If you guys know what a hash lock and a time lock is, and there's a lot of issues there. So what we want to do is just do one direction and make that a building block, because if you can get that working, you can do bidirectional with conditionals using the unidirectional as a building block. It needs to satisfy some requirements, and that's in the architecture draft. Basically, requirements relating to atomicity, the acid properties, and then non-repudiation, meaning that if anything happens, there's a crash or there's some kind of an attempt to cheat, then both G1 and G2 have sufficient evidence for, if they have to argue and they have to dispute the transaction. It needs to be agnostic to the higher level economic value. So this is actually very much like the end-to-end principle, where as we all know, in being the IETF, the IP network is agnostic to whether or not the datagram is a video, part of video, or part of a voice, or part of something else. And next slide, please, Francesca. So what do we see as items in our work, in scope of work? So we want to define the APIs of both ends of the gateway. And right now we're focusing on RESTful APIs, though if we do this correctly, then somebody can, if they want to implement it using stateful sort of messaging protocol, you could do that as well. But that's what we want to focus on today. We want to define the resource identifiers so that G1 and G2 can be pointing to the same things using the same identifiers. We want to define the message flows and, of course, the payloads that go into that message, and also a set of commands. That some of the messages are in fact affecting commands between G1 and G2. Secure channel establishment, we want to use whatever is available today. If it's TLS 1.3, great. That we don't want to do anything new there. We might extend the terminology of the NIST, NISTer 80202, which is actually a great document if you want to point anybody to a sort of reference document about terminology, because there's so much confusion in terms of terminology in this space. I would recommend looking at that NIST document. Next slide, please, Francesca. So all of this is out of scope. So we are not going to deal with blockchains and DLT systems. We're not going to propose anything new in blockchains and DLTs. We're not going to focus on consensus and BFT protocols. I know there's a lot of interest in proof of stake, proof of work, and so on. We're not going to do cryptocurrencies and tokenization. And I know some of you might be saying, oh, just if IETF would just issue its cryptocurrency, we can all be rich. But unfortunately, we're not going to do that in this effort. So we're not going to talk about incentive mechanisms, zero-knowledge protocols, another hot topic. So authentication authorization, we will use whatever has been standardized. So there are some cases where we think for, say, a private DLT system, that in order to access the resources, interior resources, in fact, the exterior resources, that the querier needs to have some kind of authorization. Well, if it uses OAuth or GNAP, great, we'll just use OAuth or GNAP. We're not going to invent anything new there. We're not going to do any concurrency control algorithms. If you look at the architecture draft, we're just taking the two-phase commit or three-phase commit as sort of the basis. It's 30 years old, 35 years old, from Jim Gray back in 78, 79. It's well-studied, well-known, implemented everywhere. If you have any kind of database in your organization, probably has two-phase commit. Identity management, so identity might be needed. Again, that's out of scope for us, and identity privacy, data privacy is out of scope for us. And the list goes on. If you have any questions, of whether or not something is in scope, just send it to the mailing list, and somebody will answer it, or I can answer it if no one answers. Next slide, please, Francesca. So some desirable features. Well, it must work if one or both of the DLTs are private, right? So this is one of the key issues today, is that we cannot assume that the world in the future will consist of one gigantic, permissionless public blockchain or DLT. That's not how the world works. In fact, there are already private DLT systems running today. If you just Google the JP Morgan, coin, JPMC coin, you'll see that the Monetary Authority of Singapore is already running, internal tests on a private, blockchain DLT. So, and also there's the geopolitical issues, right? So So for those who are following the central bank issued currency CBDCs, you'll understand that that's a very complicated, geopolitically loaded issue, and so we need to be ready for the case where the world has private DLTs. It must work if one side is a legacy system. So, for example, if you look at G1 and G2, we have to be ready. We have to design it so that maybe behind G2 is not a DLT; it's a legacy system. It's just a monolithic computer system. Well, G1 really shouldn't care about that, and vice versa, right? So that the interior, the complexity of each of the DLTs or systems behind the gateway really needs to be hidden away so that it doesn't, influence the design of the protocol. It must result in atomic settlement with sufficient evidence. I mentioned that before. And it needs to support different client modes. So in the ODAP draft, you'll see there's 3 different modes, and we think that pretty much covers, most of the types of interaction between the client and the gateway, right? And so, we can discuss that, later on if there's time, or if you have any questions about that, throw it on the mailing list, and Martin or myself or Luke, will answer that. Next slide, please, Francesca. Just to throw this out so that people know what we're referring to when we say atomicity. So we want the ACID properties to hold true when we do a unidirectional transfer. So that means in terms of the actual asset, if there's any failure, before the commit, then the transaction needs to commit or completely fail. So that means in terms of the effect on the asset must not change in terms of its ownership. Needs consistency, so a transfer must always result in the asset being in one DLT only, right? So you can't have duplicates. Isolation, while the transfer is occurring, you shouldn't be able to change the assets. So let me explain. So if Alice in DLT1 is trying to send to Bob in DLT2, while an Alice has initiated this transaction and a gateway is processing it, that asset needs to be made unavailable to Alice so that Alice doesn't use it for another local transaction, effectively doing a double spend. So in fact, we want the no double spend rule to hold during an asset transfer. Durability. So this is a big issue, and we've had discussions on this. Once you reach the last stage of the 2-phase commit, which is the commit final, and that means both sides, G1 and G2, have agreed to commit. If one of them crashes, then it needs to hold, right? That the commitment is final, and so this brings a whole lot of questions about even before we reach that phase, what happens if one of the gateways crashes, right? So this entire question of gateway crashes is a very important one, and we've got discussions going about that. Next slide, please, Francesca. So proposed deliverable. Why am I watching Intel? So that's not my slide.
No, let me just.
Yeah, I know the Ripple guys, and I know in the Interledger project. So the deliverables. Let me just continue while Francesca is talking. So I'm of the mind that I think a good working group has very specific deliverables, very well defined, possibly narrow scope, and a well defined timeline. So our proposed deliverables are architecture specification, architecture draft, the protocol draft, and the use cases draft, and we have that up on the data tracker, loaded. Optional, again, we don't want to overcommit, overpromise. 2 additional possible work items would be an asset profile Json specification. So it's basically, given an asset profile, if you guys know who the DTCC is in New York, it's the certificates depository. So if you own assets to whatever real estate in New York, that sheets of paper, you may not want to hold it. You deposit it in the safes of the DTCC, and they make a statement. But in order for G1 and G2 to be able to refer and talk about the same asset, there needs to be a standard on like a JSON, representation of that asset. So it needs to have, the issuer name, what's the asset code name, is there any denomination, it's literally, I don't want to say an attribute certificate, but it's pretty much an attribute certificate that has all the attributes of the asset. It's just a description of what it is. It doesn't say anything about ownership, status, and so on. And the most important thing, it needs to have a validation endpoint, a URL there that says, this is the place where you can, validate the status of this, this asset, particularly legal status. The other one relates to crash recovery. So in our model, G1 and G2 needs to maintain log. Right? For every message, it needs to log. So the question is, what bits of information need to be kept by G1 and G2, just in case one or both, crashes? So that's the first question. Second question is, what is the recovery model? Do we use pairs, primary and backup gateways? So all this question, very interesting, but we're going to put that in that this last bucket of log metadata, log data regarding crash. And if there is interest, then we can make that we can focus on that draft. Next slide, please, Francesca. So proposed roadmap. So we're here in IETF109 doing the presentation, and we'd like to invite people to participate on the mailing list. The mailing list is at the bottom of this slide. Our plans is to request for a BOF session at the next IETF in March, basically to ask for a working group. So the aim is basically to work on the drafts until it's reasonably mature, that we understand more clearly what is in scope and out of scope, and we identify some difficulties, quite complex questions. We'd like to, work on the 3 drafts at least, and get it finished by, the November IETF next year, and then, if that's accomplished, we can say, well, do we close down the working group, or do we recharter? Meaning, add some more items. But basically, the next sort of milestone for us is asking the ADs and the security area for a BOF in March. Next slide, please, Francesca. So I had this question actually several times from people. It's like, some people don't know who or what the IETF is. Some people do, and of course, people say like, so why the IETF? Why not go to these various organizations, and there are several, and I won't name them, and go there? And my answer is that the IETF has neutrality in this particular area. So the IETF doesn't claim to own any specific blockchain or DLP system, right? It's pretty neutral. More importantly, actually, the IETF has a long history of gateway protocols. For those who are around, back in the late 90s, IDMR, IDR, the whole discussion about, BGP. And for those who are in the IPsec working group in the late, 90s, again, we had, the IPsec and the IKE discussion, and if you think about it, a VPN box that's running IPsec and IKE, IPv1 or IPv2, it's essentially a gateway, right? A gateway that interconnects subnets or networks, or in fact enterprises. The security area has a lot of expertise in security protocols. You just have to visit the RATS working group, and what I'm saying. So I feel comfortable that we will receive sufficient criticism and positive contribution to the design. And I'd prefer to be getting these difficult questions in the IETF while the protocols are being developed, versus later on down the road when we find flaws. And for those who didn't know or don't know about the IETF, I usually say, well, IETF is the home of TCP/IP, IPsec, IKE, Kerberos, TLS, OAuth, GNAP, all the JSON encryption and signing, CoAP, RATS, and so on. And the IETF, as far as I know, has numerous liaison agreements with various organizations. I think these are the liaisons that I'm aware of, in the past: ITU, 3GPP, and so on. Next slide, please, Francesca. Oh, so that's this is the last slide. Call for, please join this mailing list. Do ask questions, because we don't know all the answers, and the more questions we have, the more clarity I think we'll get, with regards to the design of the gateway protocol. So that's the end of my slides. If anyone has any questions, should I turn off video, Francesca?
You can keep video on if you want.
Okay, sure.
And I'll mic you for anybody who wants to give any feedback. And also, there has been a lot of discussion in the chat. So, and we lost one of our co-chairs. So let's try to keep the important comments to the microphone, so that we get the good feel of the room.
Jonathan Hoyland. So if you wanted to get in here, that would have been fine with me, but I guess not. Thanks for the presentation, Thomas. I think it's certainly fine for you to have a mailing list, but I'm somewhat familiar with this. I'm somewhat familiar with this technology, though I'm probably not as familiar as you. And there's a bunch of concepts here that I think would be required to execute this successfully that I do not think are familiar to the IETF. And I have to say, I look at your current mailing list, and it seems to have like relatively modest participation from a lot of people I would think would be relevant for such a protocol. The examples you gave of the signal difference between the examples you gave of protocols that we do gateway protocols, and this is like we actually understood the protocols and largely controlled the protocols at either end of the gateways, and in this case we do not. So I guess we've had a number of proposals for blockchain work in IETF, and we've largely not done any of them. And I think that this one we also should not do for basically the same reason, which is we do not know what we're doing. And I think if you show up with major representatives from like 4 different important blockchains, then my opinion will change, or might change. But I think at the present that is not the case. Sure.
Yeah, no, agree. I think part of the sort of my approach in life is, if we don't understand it, then let's work on it so that we understand it, right? But you're right. I think our effort now is, to get a number of the participants, and I know who you mean, like this 3 or 4 of the sort of projects out there to get involved, because in fact something like this benefits them, right? And also we're trying to get the user base of the technology involved, right? So crypto exchanges, crypto providers, to get involved in this work. But no, thank you. That's very good comment, and all quite legitimate.
Thank you. Go ahead, Wes.
Thanks. Actually, I was debating whether to ask this question, and then you just led with the information. So now I want to ask the question, which is, do you have any idea how large this solution would actually apply to in the real world? I mean, are we talking just a few connections between a few various blockchains, or it's sort of an n-squared type problem, because in theory you might have a connection per every particular blockchain to every other particular blockchain, but unless you have a lot of buy-in from existing people that want to do this, I worry that it could be a lot of work for not a whole lot of gain if it's not actually going to be used. It seems like we should get a lot of buy-in ahead of time.
Agree. That's actually a very, very good question. Thank you, Wes. So actually, one of the reasons that motivated this work at this time, we could have done this 5 years ago, is a couple of things. The fact that Bitcoin is now at least 10 years old, Ethereum is 5 years old, 6 years. We don't have any interoperability between the two. Hyperledger Fabric with all its different groups, it's at least 4 years old. So we still don't have interoperability. But the big one is this question of, central bank currencies. So for those who are following this, discussion, the SEC, the Fed, the U.S. Fed, and in fact, even the EU ECB bank in Europe, they're all contemplating the need of a digital fiat currency, a digital currency issued by a sovereign government, right? That's kind of the definition. So the question is, will there be a role for blockchain and DLTs? Maybe, maybe not. There are some people saying no, we don't need blockchains and DLTs. That's fine. Some people saying no, actually we might need it. And so in fact, I personally believe that interoperability will be forced upon all of us, the whole world, if we really want to use central bank issued currency, CBDCs. So without interoperability, CBDCs will not be able to flow across systems, which is in fact, again, totally opposite than the whole idea of a fiat, fiat currency. So if you have a greenback, you can go to any bank in the United States, and that greenback represents your claim onto the issuer, in this case, the central bank, and every bank will accept it. Well, right now we don't have that, so that if I come along with a particular stable coin, there's only a limited place where I can actually be, exchanged or that my currency will be accepted. But no, that's in fact a very good point, Wes, and that's one of the reasons why we want to have a mailing list, is to get and invite all these people. Many of them are not IETF people, IETF attendees, to come and participate.
Okay, next in queue, Daniel, go ahead.
Hi there, Daniel Kahn-Gilmore, ACLU. So Thomas, thanks for this presentation. I'm still struggling a little bit with the underlying ideas. I'm in particular concerned that I don't understand if the two distributed ledgers are not using the same protocol internally, and they don't necessarily know much about how the other one works, how either one can guarantee lack of a double spend on the other one.
Right. Good one as well. So that is in fact one of the challenges, is that so if G1 is trying to transfer to G2, G1 needs to give G2 sufficient evidence that the asset in the DLT, the first DLT, has been either locked or escrowed. So there's this notion of an escrow where for example, Alice, the sender, could escrow temporarily the money to the gateway or the gateway owner until the transfer is completed. And so we need a way to enable G1 and G2 to collaborate, so that if any one of them lies, so G1 could cheat. G1 could say, hey, look, I've locked the asset and so on. So the messages that proclaim, or these assertions or claims by G1 that it's done its job in locking or escrowing, that needs to be signed by G1 and G1 in particular, so that if there's any dispute, G2 can say, but hey, 3 messages ago, you said that the asset has been locked, right? And so if there's any dispute, basically the owners, in this case, entities called VAS, asset service providers, can dispute this off chain and recover it. But this is one of the challenges. That if you want to have an opaque design, that the DLTs are opaque, then you have to solve this possible cheating problem between G1 and G2. I hope that helps. But yeah, this is why we're trying to have a mailing list. This is the kind of topics that we want to talk about. But
I just worry.
Thank you.
Sorry, that just seems like that. Your claim earlier was that you don't want the protocol to know anything about, say, the value of the asset. It just seems like that doesn't line up with what you just described, but maybe I'm misunderstanding it. It's also a funny hour for me, so maybe I'm not getting it.
So the G1 needs to use the lock or the escrow example. So if there's an asset representation on DLT1, here's 10 units of this particular asset, and the asset is described by the profile. There's a pointer or hash to the profile file somewhere, it's JSON file. And so G1 is saying that, hey, I have temporarily disabled access to this asset representation on DLT1 while the transfer occurred, right? And so that asset, 10 units of this asset is now unavailable to anyone on DLT1. And so G1 now has to transfer that to G2, in using, a commitment protocol such as two-phase commit, so that there's no ambiguity. And at the end of that transfer, now that asset has to be created. The same representation or equivalent representation has to be created by G2 in DLT2, right? And once that happens, the asset has to be destroyed or extinguished in DLT1 and created in DLT2, right? So that's how the transfer occurs. It is destroyed in DLT1. It is created in DLT2. That's kind of the model. But we're open to any kind of other model if you have any ideas about what's a suitable model to actually do asset transfers.
Okay, Phil, go ahead. I can't hear you. I don't know if you muted via the headset or something else. You seem to be unmuted via Meetico, but it could be like no, still nothing.
Do you want to type your question, Phil? Type the question in Jabber.
Whole Jabber system is dead at the moment.
Jabber's frozen for a lot of people. So there's a Meetecho outage right now, and not everybody can get into the Jabber chat.
Use the mailing list, Phil.
Not working. Okay, let's move to Wes and stay on audio just to try Phil to see if you can get it to work. Go ahead.
Yeah, he can start talking. If he interrupts me, that's great. So a couple of things with relation to the G1, G2 interfaces. I've thought about this. One, it's unclear because you've used generic terms of G1 and G2 if these are supposed to be anonymous gateways that don't necessarily have to know each other, or whether there's a business relationship between them. And there can be
stop there. No anonymity. No anonymity. Sorry, I should have put that on the slide. So gateways are owned by, if you read the architecture, okay, they're owned by legal entities. So if you want to transfer legally recognized assets, you have to be legal businesses today.
Right. Okay.
So then no anonymity. We know, in fact, that I'm saying, and people might hate this, I'm saying that the gateways need to have device identities, which is why I cited the RATS work and the IDEV ID that Michael Richardson is doing, is because the gateways need device identities.
Fair enough. The other thing that I think needs to be carefully considered is blockchains have different levels of I can never say that word, of how well somebody can remain anonymous within the blockchain, right? So the instant that you actually possibly do transfers across it, you may actually disclose an identity across that is a ramification of actually doing that transfer, and that's a security risk.
So no, great question. So that stuff occurs if you look at the architecture draft in phase 1. So right now there is a raging debate in another world, in another set of calls that I attend, and it has to do with what is called the travel rule. So the travel rule follows from the Banking Secrecy Act in 1996, when what the travel rule basically says that if you do correspondent banking, so if I go down my street here, go to Bank of America, and I say, hey, could you please transmit, $100 to Wes, actually make it bigger, $10,000 to Wes in Tokyo, Bank of Tokyo, downtown Tokyo, right? So when that happens, Bank of America has to transmit my information, personal information, which is first name, last name, telephone number, home address, account number, at least. So I'm the originator. So that's the originator information. The Tokyo Bank of Tokyo, needs to send back to Bank of America, the first name, last name, and account number of the beneficiary, in this case, say Wes in Tokyo, right? And this has been going on for 30 years now. This is the standard mechanism to do correspondent banking. So what's happened now is that the organization that defines the standards and the policies to do that, called the FATF, has just declared last year that any kind of transfer of value needs to follow the travel rules. So that means the big crypto exchanges such as Coinbase, probably one of the largest one, Kraken, if they transmit any kind of value to another exchange in Tokyo, they have to implement the travel rule, and this is a headache. Particularly this if the owner of the keypay is anonymous on the sending side. So if the originator is saying it's anonymous, the question is, should the exchange actually fulfill the request and actually transmit to Tokyo? Because now the exchanges are going to be liable legally, and they could be shut down by the SEC anytime, for failing to implement the travel rule. So in our model, we're assuming that all of that has occurred in phase one, that's out of scope for us, and that in fact the originator entity, the beneficiary entity, the gateway owner, G1 owner, G2 owner are known, and they've completed the whole funny handshake to do travel rule, and then our work really starts in phase two of the architecture draft. But very, very good question. It's actually quite a major issue today. Hey, Kathleen.
All right, thank you. Hi, thanks for the presentation. And I think we're over on time. So I just have a quick suggestion before Francesca asks the questions. Have you touched base at all with Sharon Goldberg?
At the BU?
Yeah.
Yes. I have. I know some. Yeah, quickest. Yes. Let's. I shouldn't take up time.
She's
Yes.
done a lot of work in this space. So
yeah, the Commonwealth crypto. Yeah, I know.
Yep. Great.
Thank you.
Sure. Okay, so we are out of time, and we don't have anybody else in the queue. So just for information, a lot of people have had problems with Mythical. So whatever happens today, we for sure have to get more input in the mailing list. So, but we've heard so far, and please correct me, anybody, my co-chairs, the ADs, if I heard wrong, support to create a mailing list for more discussion, and discussion is required for development. So to motivate.
List, in fact, listed at the bottom of this slide.
Sorry, what did you say?
I said, isn't there already a mailing list listed at the bottom of the slide?
That has been created, yes.
Yeah, that's right. That mailing list is live.
So I guess my put would be, let us do nothing. And if this mailing list actually shows substantial amounts of interest and an activity that we think was credible, then we can visit the question of something else.
Yep.
That's a good point. Yeah.
A good point. Thank you, Eker.
Yes. So the dispatching outcome would be create a mailing list, which has already been created, and redirect discussion there.
Hey, so I know some people are having trouble with the chat here. There's also an authentication problem happening with MeetEcho, and so we're going to have to do a VM reboot, and it's going to take all of the sessions out for about 5 minutes, and that's going to happen in 2 minutes.
Okay. Good. Thank
Sorry
you for
the interruption. Yeah.
No worries, and good that we were at the end of this topic then, so it will not kill us mid-discussion.
Maybe, Francesco, we pause for the reboot, and we come back in so it's 5 minutes, so like in 10 minutes, and get the next session started? What do you think?
Yeah, it sounds good. I hope it would take less than 10 minutes, or do we have any information about that? So it says, okay, 5 minutes plus 2 minutes. Yeah, okay, around that. I'll be back here in let's say at the top of the hour. And I will set slides. So this topic is concluded, and we have a dispatching outcome, or that will have to obviously be confirmed in the mailing list as well. But great. Talk to you in 5 minutes.
Thanks, Francesca.
We have almost everyone back yet, but not Francesca, so we'll give her a moment to join. Francesca having trouble joining. With the next presenter, share their slides so that hopefully by the time she joins, we can just get going, or I will introduce you and we'll get started.
Additionally, this is Roman speaking. MeetEcho team is recommending that you reload your window or close your tab and kind of try again if it's not working for the auto refresh.
I am back. Sorry about that.
Oh,
That took
great. Thank you.
Yes. Shimon, let's go ahead. We're a bit late now with all this that is happening. Will you be able to share the screen, or should I do that?
This is Shimon. Can you hear me okay?
Yes, we can hear you.
Yeah, if you don't mind, could you share my
Second.
slides?
You should have slides now.
Great. Okay, so I'll get started. I'm Shimon Huck, and this is actually a joint presentation with my collaborator, Ash Wilson, who will also be speaking in the second part of the talk. So if he could, I don't know what he needs to do, whether guys need to promote him to speaker or whether he can just join himself or be prepared to do so, that would be good. We would like to talk about the general topic of DANE authentication for the Internet of Things. And this being SecDispatch, I assume folks are already familiar with DANE, but just in case you aren't, the high-level summary is that it's a protocol that uses the DNS and specifically signed DNS records to authenticate X509 certificates and or public keys. So next slide, please. So some of the topics we're going to cover today are listed here. We'll go over some background on pre-existing work that we're picking up again. So this is DANE for TLS client authentication, for which there are a couple of drafts that you may have seen announced on the mailing list recently. And we'll summarize past engagement on this work and who is interested in advancing it. We'll also mention some upcoming work that we're planning to do. And what we're hoping to get out of the discussion today is where, in terms of IETF venues, we might pursue this work, and also to generally get feedback and recruit others into helping out if there is interest in these topics. Next slide. Okay, good. So the two drafts that we currently have were originally developed in mid-2015. The first, TLS client authentication via TLSA records, specifies how to do DANE client authentication in TLS. And the second one defines a new TLS extension to convey a client's DANE identity. The original target use cases were one, IoT device authentication, and second, authenticating clients in SMTP transport security. For the second case, you may be aware that that's an area that has already seen some uptake in DANE authentication on the server side. We presented this work back in IETF 93 in the summer of 2015 in the Dane working group, which existed at that time. So I provided a pointer to the slide deck for that presentation. There was quite a bit of subsequent discussion on the list around that time, but then the Dane working group shut down because it had finished its original charter of work, and the authors didn't really have the time or energy to continue pursuing it. But in the intervening years, I'd say we're approached pretty regularly by miscellaneous parties, many of them in the IoT space, about reviving and continuing the work, which we are finally planning to do. So next slide, please, Francesca. All right, so I'll give a quick protocol summary now. The TLS client has an identity in the form of a domain name, a public and private key pair, and a certificate binding the public key to the domain name, and there is a corresponding TLSA record published in the DNS. The TLS server sends a certificate request message in the handshake, extracts the client identity from the presented certificate, obtains the TLSA record and validates it against the certificate or the public key in the certificate. And we also have a new TLS, proposed new TLS extension called Dane Client Identity. It has a couple of purposes. First, to signal support for this protocol, which can actually be done with just an empty extension, but it can also be used to convey the actual client's DNS identity, which is needed to support, for example, TLS raw public key authentication as described in RFC 7250. The draft currently mentions using ECH, encrypted client hello, in the latter case to protect the privacy of the transmitted name. And that part is likely going to change based on discussion that has happened recently. So Eric Rescorla has reviewed the draft on the mailing list and made some suggestions that we're considering. In TLS 1.3, we can actually place these extensions in the certificate request and certificate messages, which are both encrypted, rather than in the client hello and server hello. And then we don't actually need to resort to ECH to protect the first flight data from the client. Then the remaining question would be what to do about TLS 1.2 support. There was another suggestion about modifying the extension data definition to properly allow extensibility, and there have been some back and forth comments about that list that need to be sorted out too. Next slide, please. So the newly refreshed versions of these drafts have a few other small changes from the original versions, and I'm just going to quickly summarize those. The main two ones are simplification. Originally, we supported 2 subject alternative name fields in the certificate, DNS name and SRV name. That's RFC 4985. So we now specify only DNS name. SRV name is really, as far as we can tell, not used in the real world, at least not yet. And if we need to specify service-specific identities, the DNS owner name format in the TLSA record can easily encode an application-specific label, which it already does in one of the proposed formats in the draft. The second one is relaxing the record name format. Originally, I think we were too proscriptive with the format, and that aspect of the draft caused quite a bit of arguing on the list. Different applications will probably prefer different formats anyway, so now the draft just recommends what we might think could be widely applicable formats, but allows others. So the other part of the work that we want to discuss is we want to expand the scope of the Dane for IoT work. So in particular, object security applications of Dane, there are quite a number of folks in the IoT space that would like to use Dane more generally for object security. So neither of the currently defined records, TLSA or SMIME, are well suited here. TLSA currently is defined for TLS channel authentication only. And SMIME is object security for email applications, and further has a record format that is defined in terms of email identities. We could, of course, propose a new RR type, but that means a much longer development and adoption cycle. And TLSA is already widely known and in use. And the proposal on the table, which Ash will talk about in much more detail, is to extend its scope to cover this use case also. We also would like to use DNS and DANE more generally for certificate discovery, and I'm going to defer that part of the discussion to my co-presenter too. Next slide, please, Francesca. As for who wants to advance this work, well, the authors naturally, but there's also quite a bit of interest from colleagues that we have in the past and are currently speaking to at places like NIST, ICANN, and the LoRa Alliance. That's an alliance of LPWAN device manufacturers and more. So at this point, I'm going to switch over to my co-presenter. But before I do that, I wanted to see if there are any questions or comments on the currently published drafts about DANE TLS client authentication.
Elliot, go ahead.
Hi guys, how's it going? This is Elliot. I just had one quick question about your draft, which was, can you say more about the IoT aspects that you expect? You guys talk about it in the draft, but it's, I think you spent about a half paragraph, and could you elaborate just a bit?
Oh yes, we definitely can. So I think what I'm going to do is I'm going to defer to Ash, because he's going to talk about the IoT motivation and use case in much more detail. So I think you'll get your answers there, Elliot.
Thank you very much.
All right, thanks a bunch. I think I can take it from here. This is Ash.
Yep.
Thanks, Shimon.
Go for it.
Can we advance the slides, please, Francesca? So to sort of frame our thinking on IoT device identity, in a very basic sense, a digital identity is a name and a way of proving ownership of a name, and the value of any sort of identity strategy or identity system is how widely the name is recognized and how resistant that system is to impersonation attacks. The challenges with IoT specifically is, with decoupled applications, its certificate discovery becomes difficult. You end up with proprietary APIs that are operated by certificate authorities, and the message consuming application that needs to authenticate messages across a decoupled application then has to interact with that certificate authority, consume and synchronize those certificates. So that's one challenge. There's a problem of subjective entity names that we oftentimes see within within device certificates, and you have a possibility of namespace collisions. You're really only guaranteed the uniqueness of a name within the scope of a certificate authority, and that's another problem that we seek to mitigate. One of the ways that the industry is trying to mitigate the problem of going across roots of trust is we're seeking to solve that with solutions like Brewski, right, where you can automate a great deal of the onboarding process from manufacturer issued PKI to locally issued or enterprise PKI. Together with all of these other problems, the fact that these platforms are really quite constrained. And the example that I'll give is the Espressif ESP32. That's a really very common and widely used system on a chip that you often see shipped with about 4 megs of RAM. If you want to put the browser CA bundle on it, for TLS, just the server authentication aspect, then that's 1.2 megs that you're dropping onto a 4 meg flash chip. And so it doesn't, I guess an inelegant is a pretty good way to describe that aspect. Could you advance the slide, please? So DNS is definitely the most widely recognized namespace on the internet, and public key authentication is quite resilient to impersonation. Dane gives us the ability to use these two together. It's a way of binding a DNS name to a public key, and this gives us an identity system that's resistant to collisions, even across certificate authorities, because even if two different authorities issue against the same name, whichever public key is associated with the name in DNS is the one that wins. You don't have to worry about, proprietary interfaces with CAs, proprietary APIs, because the SDK for that interaction is already baked into the operating system. You can attribute, device behavior via the DNS hierarchy to whoever actually owns the identity. And that also gives a way to sort of repudiate that identity too. You can tombstone the record, or you can just delete it if that device should no longer be trusted. And the current public key is always in DNS. This can fit in with certificate rotation policies, and enable better sort of identity hygiene. And then you don't actually have to distribute certificates to authenticating parties when you consider like a decoupled architecture. This is a discovery mechanism as opposed to distribution, and the analogy here is sort of like the host.txt file originally, right? That sort of prompted the need for DNS is because it became unwieldy to move around this host.txt file. It was enormous, and the rate of change was high. Not exactly the same, but similar. We have managing certificate authority, CA certificates for validating certificates can get that unwieldy for devices. So moving from a distribution model to a discovery model can bring some elegance and simplify some things for certificate discovery in IoT. Next slide, please. So digging a little bit deeper into the implementation aspect. This actually borrows from what we saw in the Freeland-Barnes certificate ID format for devices. This was a draft a few years ago that was presented, but it suggested the use of an underscore device label, within the certificate. And we think that actually fits pretty well here because it gives us a delegation point, or a point beyond which we can delegate, to either a third-party provider or, to a specific system that's under the control of whoever's managing the device identities for an organization. And similar to how the SMIME cert label works in 8162, everything under SMIME cert is a human identity. And, in this sense, this would be everything under underscore device would be a device identity. Another difference in the two is this doesn't carry the complexity that 8162 has for hashing the email address local part to get something that's compatible with DNS. Devices would just have simple DNS names, and then you could have sub identities. If you wanted a device to have multiple certificates associated with it, then you can use different labels, say underscore labels on the on the far left of the DNS name, for SMTP clients, things like that. The record type that we propose to use is TLSA. There's no need to change the format of the record to serve this use case. Already works really well. And this doesn't have to work exclusively for IoT. We've gotten some feedback that this might actually work pretty well for other applications, microservices and things like that. And since we're binding this to the universal namespace of DNS, then you could actually pretty easily and simply describe trust across organizations, where you may have a client within one organization that's reaching out to a service that's presented by another organization, and they can do mutual TLS using Dane. Next slide, please. There are a few places in the stack where we think that this could that this could benefit the ecosystem, right? There's network authentication, transport authentication. Further up, there's message authentication, and wrapping all of this together, you get an authorization policy that starts looking like network access control lists. I'm a former network engineer, so this is just sort of how my brain works. Next slide, please. Digging into the network authentication use case, this can be used to simplify radius configuration. Radius oftentimes for ETLS involves interaction with certificate authorities and managing all of that stuff. With Dane, it becomes as simple as managing a list of entities which are allowed to access a given VLAN or SSID. And so, your Radius server really only needs to contain a list of identities, and it uses those against DNS to pull the public key to authenticate the device, as opposed to having to manage a certificate authority, the challenges that come with the subjective naming that can come along with that. This we think really cleans up the use of ETLS and can lead to wider adoption of X.509 based authentication for network access. And it also makes the support for raw public keys, in that case, a little simpler too. Raw public keys, which is essentially a certificate with all of this stuff like the issuer information, the issuer's signature, the entity name, and everything else stripped out of it. It's just a public key, so it doesn't bear all of that other metadata that's oftentimes used to correlate, with a named identity. And using DNS to host those raw public keys takes the burden off of the network administrator or the Radius server to correlate the name with the public key. So we think this simplifies that as well. Next slide, please.
Ash, I'm just going to interrupt you quickly just to let you know you have around 10 minutes left. And I suggest we move quickly to the discussion part, which is most interesting to get to the dispatching outcome. Go ahead.
Certainly. All right. The transport authentication aspect we've already covered in some detail, and that's just being able to do mutual authentication between two entities, regardless of the certificate authority. This we think works pretty well with multicast DNS. As a companion technology, multicast DNS gives us the ability to, DNS service discovery on a local network to announce, this is the service I'm providing, this is my identity. The identity can then be confirmed using Dane and the public DNS, as a part of that process for authentication. And then you can very simply describe trust as, this device may act as a client with this server. It can be objectively interpreted. It can be interpreted by humans, audited. Just becomes a lot easier to, to understand and to parse policies from a machine and human aspect. Next slide, please. Object security, and I'll go into more detail on this in a little bit. The challenge, one of the biggest challenges with object security is getting the certificate to the authenticating party, and then also getting the public key to the sender if you're trying to do end-to-end encryption. So using DNS as that certificate or public key discovery mechanism really simplifies that. And again, you get the benefit of working across CAs. And then policy in this case can be described as, sender may use middleware to reach recipient. It starts to look a little bit like a policy route. Next slide, please. Life with Dane. We think that identity suppliers will be able to ship more useful identities. And this could be in the form of SIM cards, or UICCs, even, TPMs, trusted platform modules, things like that, can have identities that are authenticatable using DNS, as soon as they're plugged into the device. And then implementers get the benefit of being able to roll these devices out more quickly. without having to rekey to enterprise PKI, and application owners can get the benefit of a standardized application or authentication protocol. And hopefully this will lead to a state in the ecosystem where you can choose best of breed components. You don't always get, sometimes you have to buy your imaging devices from the same company that produces the software you use for computer vision, and they're not always good at both. You just kind of have to figure out which one's more important and go with that. We're hoping that this opens it up for application owners to pick best of breed equipment too. Next slide. Current work centers around using Dane for mutual TLS. We think that beyond mutual TLS, there might be a benefit in OAuth 2, which supports mutual TLS, and EAT TLS. We think that may work with little or no modification once the TLS library supports the use of Dane client certificates. Next slide, please. Upcoming work using Dane specifically for certificate discovery across decoupled applications. This is something we refer to as Dane Lite. Uses the TLSA record to represent the certificate and still uses PKICs to authenticate the certificate. And we would propose this as a separate and very focused use case with a different certificate usage mode called PKIC CD. The ultimate goal, we want DNSSEC everywhere, but because DNSSEC adoption is so sparse, that's an inhibitor to adoption for this. So we think that using it like this, we can still safely use the record and authenticate what's coming across and incentivize the use of, or the further adoption of, DNSSEC down the road. Because if you can use the TLSA record specifically for authenticating messages in a decoupled application, wouldn't it be really nice if you could just use that for mutual TLS authentication? Well, then it becomes a simplification, and there's a usability benefit to adopting DNSSEC beyond the security benefits, and you can then turn DNSSEC on, and you can start migrating these over to the cert usage of 1 or 3 or whatever. So I realize that we have covered an awful lot, and I think we can kick to the I guess the question now is how should the work continue, and should this land with the TLS group, with UTA, DNS op, or is there a better working group this could land with? And now is probably a pretty good time for Q&A.
Good time to start the discussion. Richard, did you want to say something?
No, I was just going to say the same thing you just said.
Good. There is some discussion in Jabber going on, which have been, okay, Phil, go ahead. Let's try this.
It's working?
Yes, yes.
No, I can't hear you.
Was working, and then it stopped working. Phil, can't hear you. Okay.
Can't hear you either.
No, it's not working. Elliot, you went into the queue.
Yeah, please.
Go ahead.
Should I go ahead? Do you want me to go ahead?
Yes, go ahead, Elliot.
Okay. Yeah, we're having this pretty lengthy discussion in the chat. Phil, we can't hear you, so just bear with us. But there's a couple things tied together here. I suspect people need to understand quite a bit more about this proposal before it goes forward. For one thing, I have lots of questions about dependencies relating to it. It's interesting, but it's also one of something close to a half dozen similar mechanisms that each offers a slightly different claim. So we probably need to consolidate those discussions a little bit. Maybe the thing to do is to push it into a BOF. Maybe the thing to do is to bring it into the pondered IoT ops group for discussion and then dispatch from there with these other mechanisms. Those were the thoughts from, I think I mentioned some of that in the chat. I'm not sure what other people think, but at least the idea is worth pursuing a little bit to clarify what claims are being offered, what environments can work in, what environments it can't work in, and how does it compare to the other mechanisms that are being put forward. And we did have a little bit of these sorts of discussions in the side meetings for onboarding, but we haven't really carried those forward, and maybe we should, because there are also a bunch of mechanisms outside of the IETF that we need to view in this context, especially in the context of IoT. Thanks for letting me blather on a little long here.
So Elliot, is IoT Ops, is that an existing working group or a proposed one? And is that where you were proposing to have the discussion?
Yeah, it's proposed, and we'd have to run it by Rob Wilton, and maybe that we should have that conversation as time goes on. I'm not sure how you want to handle the dispatch here, though. I realize that timing is not perfect.
Okay, thanks, Elliot. Anybody else who wants to come to the mic? No. Okay, so I heard. Go ahead, Richard.
Yeah, I think I was going to go in the same direction you were and try and kind of start summarizing based on the discussion on the audio and the chat. Oh, we have one last person in the queue. Roberto, did you want to say something? I guess not.
We can
So,
hear you, so.
Yeah, Roberto, feel free to turn on your audio if you can get that working. So I was going to try and summarize. It sounds like based on the discussion in the audio channel here and on the chat that there's a fair bit more sorting to do here. So this might be best suited for a full-up BOF to, as Elliot pointed out, collect some related work and get a more holistic view to this before we charter up a specific solution. So I would put that forward as kind of a proposed resolution for this one.
Anybody strong objections to BOF? Is there a discussion list? And
yeah, I was going to say that would be another precursor we could do is set up a mailing list to discuss these sort of authentication requirements.
So Elliot is suggesting this IoT onboarding mailing list. So that sounds good.
Okay, that's an existing mailing list, or you're proposing creating that? Okay.
And Stephen, go ahead.
So I wasn't clear what the topic of the BOF Richard was imagining what would be.
I would probably defer to other folks with a little more expertise than me here, but it sounds like folks had in mind something slightly broader than just this topic, covering some slightly broader frontier of different IoT authentication and identity provisioning technologies that are out there. But I see Elliot in the queue now, so go ahead, Elliot.
Yep, you just said it pretty much there, Richard, which is we should look at this mechanism. We should look, I think, at the mechanism that Dan Harkins and our colleague from Malaysia have put together, which is a TLS POK draft, which is related. There's TEEP work that's related. And of course, there's all the Anima ACE work that needs to be considered as well. And I think you might have some related work as well, if I understand correctly.
So Michael was writing in the chat. I think you is probably Richard. Yes. Non-working group forming buff. I don't know if we discussed the non-working group forming or working group forming part of it. Any opinions? Ted.
So this is
or Roman. Roman, go ahead.
So I was going to say, I think non-working group forming is probably right at this stage, because one of the biggest problems you actually have is how do you get unique names to these devices that are usable in this context for the people who want to identify them. And I think both Phil and Ecker kind of laid out in the chat good reasons why the names they're commonly known by simply won't work here. And so I think without that framing discussion first, going into the methods isn't going to help a lot, because you're arguing about the utility of something attaching a trust anchor to a name that isn't unique. And that's really problematic in a whole bunch of ways. So I think a non-working group forming off that took a bigger framing question and then invited people in to describe why their solutions took their views of it would be more useful to make progress here. Thanks.
Yeah, so thanks for that comment, Ted. So I think we are expecting the names to be unique. So there's a provisioning process by which unique names are deployed on the devices. I don't know if Ash's presentation touched on that, but that is at least our expectation.
Yes, that's correct.
So I think that is your expectation, but I think the huge number of these devices, that expectation would not be met.
Okay, we
Correct.
need to stop this discussion here. But I think Roman wanted to say something before. I don't know, Roman. Or AD. If not,
I think Roman lost Mitico connectivity. I don't know if
okay.
Ben Kadick is on the line. Is our other AD?
Ben, go ahead.
Yeah, this is Ben Kadek here. I mean, I think there's not a super clear outcome, but I agree that there's a lot of things going on in this space, and at least I don't have a great understanding of even the scope of the work that was presented here. So it's definitely in a further discussion, whether that's on email list or off. I don't have a great picture myself.
Okay, so I would say the conclusion from both. Next step is both, and continuing the discussion in mailing list proposal was too high on the chat. Someone post what mailing list was again? It was in IoT Ops, but IoT Onboarding. Thank you. So we continue the discussion there, waiting for the BOF opinion there as well. And thank you, Ash and Schumann, for presenting.
Yeah, thanks. Can I just ask one quick question before we move on?
Go ahead.
So we'll start the discussion on the IoT onboarding list, and then the proposal to submit a BOF would be, if I understood Elliot's suggestion correctly earlier, was to cover the DANE for IoT topic as well as a set of related protocols that intersect in this area, right? So if I could ask Elliot to summarize the set of things that he mentioned, the related technologies and protocols. Maybe
actually,
an email to the SECDISPATCH list, that would be good.
This is a good point to remind everybody that in this working group, we actually dispatch the work. to whatever dispatching outcome we recommended is actually done. So you can always come to the chairs for more indication of what that meant. But yes, let's take this offline.
Okay, great. Thank you.
Thank you. Next
Thanks
up, Stefan.
Hi, I'm trying to share my screen here.
And nice to see you as well.
Great. So you have my screen?
Yes,
and
we can see the slides.
Good. So thank you for the opportunity to present the signature validation token. As we mentioned at the beginning of the meeting, this item was briefly presented and discussed at the Security Dispatch IETF109-SECDISPATCH-20201116-0900. One of the news here is on the first slide is that Russ Housley has joined me as an editor for the IETF drafts that are actually now posted to the IETF. We have 3 drafts on this, and so let me go through quickly and briefly. The goal of this work is to provide a simple solution for validating signature in the distant future. This is an area where there is a great need and also a great potential of doing something that is not available through current solutions today. The history of this work is that it started up as a Swedish government-funded research project for archival of electronic signature. What do we need to do in order to have effective archiving of electronic documents? There's a huge potential savings in being able to doing that. This work got adopted by the Swedish Agency for Digital Government and now is a first standard for how to do this officially in Swedish government work. It has been developed in a public available open source, and it has gone into production also in the EduSign service. I will talk a little bit more about that. It's a signing service for the Swedish educational environment and for the school systems in Sweden. And now we're approaching this in the IETF for standardization, not rubber stamping, but we have a version 1.0 of the protocol, and we would like to develop for 1.1 within the IETF to have IETF full in control of what happens and change control of that next version of the protocol. And the important requirements that should be satisfied with the solution is, first of all, there are solutions that do not integrity protect the document that they're being protected here. But this solution needs to fully integrity protect so that if anything changes in the document that's been archived, and when you pull it off, this evidence should not work anymore. It needs to be easy to implement. There is a great need for simplicity here. We need absolutely a predictable outcome. That is nothing that is not currently provided by current solutions. If you validate the signature today and you archive it and you pull it out 10 years from now, you might come to different conclusions just following the validation procedures because some external information has or condition have changed. We want to avoid size explosion and especially cascading evidence collection. Signatures are supported by external evidence, and when you have external evidence that require another piece of external evidence, and that requires another piece of external evidence, you get a cascading effect that we need to avoid. We want to avoid repeated storage of large common validation objects. If you're storing 100,000 documents and all need support of a 50 megabyte CRL, then storing that 50 megabyte CRL in each of those 100,000 documents is not very efficient. We want to provide fast verification, and then more importantly, it should all work offline, not because we don't foresee an online capability in the future, but anything that needs to be available online might not be available in the future. And it must be compatible with current document parsers and signature validation software. It should not interfere with processing these documents in any software that doesn't know anything about the solution. It is up and running in production version 1.0 in EduSign, which is a solution provided by Sunet. Leif Johansson, that is well known here in the IETF, is handling this service, and you're free to approach him about the choice to use this. And this is used to ensure that everything that is signed in EduSign can be archived and be validated in the future, which is a key feature that is required by the educational system in order to use the solution. This is not different. Using the signature validation token is not different from any other signature validation because they all require some sort of external evidence. No signed document solution can validate signature in a self-sufficient manner. In the easiest case, where the signature certificate still is valid, I still need to know is the signature not revoked or not. And if this is revoked, I also need a time when the signature was created before it was revoked or not, in order to do signature validation even of documents where the certificate is valid. After the certificate expires, I need to know a time when the signature existed, and I need to know the validity status of the certificate at that time. Then, when the algorithms are no longer trusted, or if the key has been exposed or anything like that, I need more information. I need still a time where the signature existed. I need the validity status of that time of certificates and other. And I need the data that it was actually signed, because I could have altered that signed document that made that fit the signature. So I need to know actually what data that was signed at the time. And I need to know all the certificates that were used. And it would help also to know results of prior validations. And one of the problems with current approaches is the cascading evidence collection. And that is the main area of improvement where we're trying to fix with this approach. In the current situation, I try to validate the signature. And that signature is supported by cert, and that cert is supported by chain. And to validate that chain, I need to support by OCSP tokens that is supported by cert, and that CA cert is supported by CRL. And then in order to know a time when this was valid, in case something happens, I need a timestamp, and I have the same problem with cascading evidence. And they all end up in a trust anchor. And I may know if that trust anchor is trusted today, but I may not know in 5 years from now if that trust anchor is still able to be determined to be trusted. And then to have the long-term validation, I need to timestamp all of this information by we'll call a archive timestamp. And this archive timestamp needs to be supported by supporting evidence. And since the timestamping authority does not see the document or don't know if anything else is valid, it's only making it a statement of this existed at a certain point in time. And if you need new evidence, you need to create a new archive timestamp that includes the first one. The problem here is that any piece of evidence that is not valid in 10 years from now will destroy the whole chain of evidence. This is not like I have 100 parallel sources of evidence. I have 100 serial points of evidence, and anything that is not verifiable tomorrow breaks the whole chain of evidence. So the idea here is to reduce this and to replace the cascading evidence with one piece of evidence in order to increase the predictability of the outcome and remove the complexity. And that is replaced with the signature validation token. And the signature validation token put everything in one evidence. And you collect the signature validation token when everything is fresh and can be checked in current time. So the token includes information about who's the issuer, the time of issuance, the algorithms used to create this token, if there is an expire of the token, and then it has a hash over the signed document. It has hashes over the signed attributes, which is like signed attributes in CMS or signed info in XML. It has a hash of the signature value and the hash of the certificates that were validated. Then we can add information about verified times that we have verified and how we verified them. And also we can include the results. The new now, how we use this is that it's free for the validator to use whatever part of this evidence you feel are necessary. You can use only the claim that the certificates were valid and validate the signature while it can be validated. But you can also choose to rely on the whole conclusion here. But you can essentially replace the need for all the cascading evidence with one piece of evidence. It's very space efficient. Sorry, it's space efficient. So this is the example of the format with compressed information. If you show this, how this looks live in XML, it doesn't take very much space. It's extremely much space efficient than, for example, storing CRLs and OCSP responses and certificates of all cascading evidence in a signature. The validation process is pretty simple. You look at the document. If it has a validation token, you validate that. If it doesn't have a token or it can't recognize a token, you go to the traditional validation process. You come up with a solution. And in the validation, you choose whatever you think you want to use from the supporting evidence in the validation token in order to do this.
Stefan, just to, sorry to interrupt, but you have 2 minutes left.
Okay. So basically, we have profiles for PDF, XML, and JAWS, and we have drafts on the internet. We have open source available, and we have a test site where you can test, upload any European validated signatures or qualified electronic signatures. And you can download this document with a validation token. And once you're validated, you can revalidate it with the signature validation token enhanced process. And if you look at this in the PDF processor, you will see that the signature validation token appears here just as another document timestamp. The IETF, why is because this is, first of all, based on a JOT format that has a roots in the IETF, and IETF has done similar work in the past. And now we think that LAMPS, because it's CMS related, would fit into the LAMPS working group to work on there. And questions. So that's all I needed to say about it.
Thanks, Stefan. So comments. This work was dispatched at IETF109 with more. The outcome was more need for discussion, and I'd like to hear if people think that things have changed enough. So I am hearing that obviously the authors think things have changed enough so that there should be a different outcome today.
Yeah, so we don't want to change the dispatch, what has been done, but we do want to hear the feedback in case something has changed. So if people have comments, please come to the mic.
And also there is a lot going on in the chat. So either people in the chat come forward. Roberto, go ahead.
Nothing in the chat so far has, said anything that suggests a specific working group or anything along those lines.
Oh, can you hear me?
Yes.
Oh, thanks. I'm Roberto Polli. I know that there are some other organizations in Europe that are trying to standardize a JSON profile for storing signatures, just like EI does profiles for JSON. And something I saw before was quite similar of what was presented. And I was guessing if you had any talk with them, or if you managed to put in your specification all the IDaaS requirements. I think that this work is interesting, and I will be interested to talk whether it makes it into the IETF or not.
I could answer that very well. The work done in CESI is another type of. It's not this kind of solution, but it's another type where you include all that cascading evidence in the signature, and they all have that for PDF, and that is completely complementary to this work. You can use that kind of cascading evidence into doing the conclusion of creating a signature validation token. So there is no conflict here. They do standards how to include cascading evidence in a document, and this is another approach. And this is completely compatible with anything that is designed in the IDaaS. There is no preference in the IDaaS how long-term validation should be done.
Okay, really quickly, Hank, we have 2 minutes left.
Okay, is my audio fine?
Go ahead.
Okay, thank you. So I hope you can hear me. I really like this work. It's basically offloading the burden of appraisal of old stuff to another entity. Now you can trust this entity. My question is, you're using tokens here, and I have to admit I fast read the document, but I did not find it. How long are these tokens supposed to live? Is it like a service you can request them if you receive something old, or is it like a substitute and it lasts for years? Because tokens typically are short-lived.
So that's a policy decision, but they are not assumed to ever expire, because the statement they do never expires. The statement is, this is what I checked, and this is the conclusion using this policy that I came to. And that is a statement that never expires. So you could do an expiration. There is in the standard you could have, but you could also let them live as long as the crypto that supports them is supporting them.
Okay, so the reliability, the resilience of this service or this entity is higher than the substituted authority that was vouching for or creating the certificate in the first hand here, yes? So there's a higher level of assurance.
You can replace this one. You can replace this one with another one, and you can also replace it with more using different algorithms. If you think that you want to have a bigger bet that this sign with this algorithm will live longer than the other one. But the validation process is exactly the same if you replace this with the new evidence in the future.
Okay. I would have,
Okay,
yeah,
so
I understand. Sorry, Francesca. I will stop here right now because we had a talk about. I'm sorry. Yeah, okay, bye.
Yeah, thank you, Hank. This seems to have been looking at the chat and reading the feedback. I think that the outcome is still the same. It needs more discussion, and what probably not continue, it would need a new working group. So I recommend in the SECDISPATCH mailing list so everybody can join there. And yes, let's conclude this presentation and the meeting. Thank you, Stefan. I think to summarize, let's see, let's do this real quickly. So for the interoperability architecture for blockchain gateways, so we have the mailing list, blockchain interop, and we need more discussion and community development in that mailing list. For the DANE for IoT security, we recommend a BOF to discuss more. And then use IoT onboarding mailing list in the meantime for discussion. And for the SVT, we still recommend more discussion in a mailing list to be created. And all of this will be, of course, confirmed in the SecDispatch mailing list. And we hope to advertise the different discussion. We'll ask the different authors to post a thread in the mailing list to do so. And with that said, we are 2 minutes over, and thank you so much for joining, and I'll talk to you very soon. Bye.
Thank you, Francesca and Richard.
Thank you to the chairs.